بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to welcome all of my students from grade 12 into their second video of the lessons of mathematics. And in this lesson, we will carry on with our topic from the last class, which is permutations. We have started with this topic previously in the first video, so please make sure that you watch the first video before watching this one. In this video, we're going to extend our lecture, solving some extra exercises, starting with the homework exercises from the first video, and we will also discuss some new ideas as well. So I will start with a discussion of some, not all, but some of the homework questions. Now, I have given you a homework assignment in the previous video, and today I am going to discuss some of the questions that we assigned as homework. And the first of these questions will be question 2. In question 2, I think I gave you both B, E, and F. We will see together how do we solve part E first. So in part E, what was required is to express in the form in permutation R. So they wanted us to write the answer that we already have as the form in permutation R, and the first one was part E, and in part E we had n-1 multiplied by n-2 multiplied by n-3 multiplied by n-4. So this one was quite straightforward. It's not that hard. All what you need to know here is that we have 4 actions. So here we have 4 actions. 1, 2, 3, 4. So when you write it as a permutation, you write here 4, since you have 4 actions. And then you are going to write the largest one in the sequence, the largest number in the sequence. Of course, the largest number in this sequence is n-1, so this is going to be here. So it's going to be n-1 permutation 4. I hope that this one is clear enough. And let's see, let's move on to the second one. Okay, now, another one was F. And in this one, what was required to do is to write this n cubed minus n multiplied by n squared minus 4. They wanted us to write this one in the form of a permutation. Now, this one is quite different because here we don't have a clear sequence of factors. Now, in the previous one, we have a sequence of factors. So n-1, what goes next is n-2, what goes next is n-3, and then n-4. So we have a sequence of numbers. These numbers decrease by 1 every time. But this time, we don't have a sequence of number. You see here we have n cubed minus n, and here we have n squared minus 4. These factors seem at the beginning as they are not related at all. So the way we solve this one is to try to work with the factors that we already have first. So we can't start right away with the answer. We don't have a permutation for this because it's not a sequence. We have to change it into a sequence and then see how it goes. So what are we going to do? From this first factor, I can take n as a common factor. And if I take n as a common factor, I will be left with n squared minus 1. So we took n as a common factor from these two out. You have n cubed. You take n out, you still have n squared. And here you have n. You take it out, you still have 1. The second bracket is going to be n squared minus 4 as it is. Now, I just want you to remember something. Now, I want you to remember that if you have a squared minus b squared, then this is a difference of two squares, which can be written as a minus b and a plus b. Good? Now, we actually have the same case here, since we have difference of two squares right here. So n times n squared minus 1, this can be n, and then two brackets, and these two brackets are for n squared minus 1. It's like a squared minus b squared. 1 is actually 1 squared. So when you factorize it using difference of two squares, you will get n minus 1 and n plus 1. Good? So what we did is we factorized the first bracket we have, which is n squared minus 1, into two brackets, which are n minus 1 and n plus 1. We can do exactly the same thing with the second one here. So it's n squared minus 4. We can factorize it also into two brackets, and we will get n minus 2 n plus 2. Now we have 5 factors. Yes, we started with 2 factors. Now we have 5 factors, but these 5 factors actually are in a sequence. The largest one of all of these factors is this one. So it is, let's reorder it. So reordering the factors. What we get is the following. This is the largest factor, which is n plus 2. So it goes first. This is the second largest factor, so it is n plus 1. And then the third one is n. The fourth one is n minus 1. And the fifth one is n minus 2. Now we have a sequence of factors. There are 5 factors that come after each other. So it's a permutation in which you have 5 actions. And the largest one of these actions is n plus 2. So this is going to be the correct answer. Remember, you can have a question like this in a multiple choice question or a true-false question. I can give you this one and tell you it's equal to the permutation of n plus 2 permutation 5, and you tell us if it's true or false, or maybe you can select this from one of the choices. I hope this one is clear. So this is what I want to discuss with you from question number 2. Let's see, as part of the homework as well from the previous class, I gave you question 1, but I trust that question is quite easy. Please solve question 1 and make sure of your answer from the answers at the end of the lesson. There is this one in question 3. In question 3, let's see this one. So in question 3, what we wanted to do is to find the value of n. So we were required to find the value of n. And in this part, which is part D, I gave you D as homework, I had n 5 permutation 3 equals 7 permutation 5. I trust this one was easy, but let's do it anyways. So solving this one, the first thing that we will do is we'll write n as it is, and then we will solve this one. So I have 3 actions, and these 3 actions start with 5. So 3 actions, 5 is the largest number, the second action is 4, and then 3. So it is n times 5 times 4 times 3. Equals, here we have 5 actions, 1, 2, 3, 4, 5, and they start from 7. So 7 times 6 times 5 times 4 times 3. Good? So this is our first step. The second step now is to cancel whatever is similar from both sides. So I think you can see that we can cancel the 5 with the 5, the 4 with the 4, and the 3 with the 3. So I think we're left with the answer. So here n, that's the only thing we have now, n equals 7 times 6, which is equal to 42. So this is the value of n. Good. And with this, we will be done with discussing the homework, and we'll take a small break and then come back to solve some new questions and new ideas. Okay, so we're back from the break now, and let's carry on with some new ideas and some new exercises. These questions I'm going to solve now are from exercise 2-2. They are from exercise 2-2, and this exercise is on page 80. So I have selected some of the exercises to solve now with you, and I'm going to leave some of them as homework for you. So let's see. I will start with question number 6. So in this question, the question says the following. You can follow with me from your books if you want to. Please write this in your copybook. So find r plus 1 factorial where 8 permutation r is equal to 6,720. So this is what's given. We are given that 8 permutation r is 6,720, and this is what they're asking us for. So they're asking us to find the r plus 1 factorial. And to do that, we need to find the value of r. So how do we find the value of r? Well, r is here. It's right here. And if we find how much is this number, we can just substitute it here and find how much is r plus 1 factorial. But how do we find it from here? Well, it's quite easy, and I think we've discussed this before in the previous class. And the way we do it, I told you that you can take 6,720 and you factorize it. You get the prime factors of this number. Okay? So we will get the prime factors of this number. And just a reminder, the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. But what we actually care about usually is the first 3 digits. And in the previous class, in the previous video, we discussed how do you know if a certain number is divisible by one of these or not. So by 2, yes, this one is divisible by 2 since it ends with an even digit, 0 or 2 or 4 or 6 or 8. So this one actually is divisible by 2. And that's why the first number that we will divide by will be 2. So let's divide by 2. 6 divided by 2, we will get 3. So this is good, 3. 7 divided by 2 cannot be done. So what you need to do, you need to reduce from the 7. I am going to reduce 1, so I'll get 6, and that one is going to be here. So 6 divided by 2 will be another 3. So this is also 3. And then 12 divided by 2, you will get 6. So this is 6. And then 0 divided by 2 is 0. Good. So we got 3,360. Of course, if you can do this, with your mind, you don't need long division like this one. Just do it, okay? So let's do it again by 2 because it's even. So 3 divided by 2, this cannot be done. So what we need to do is we need to reduce this. So it becomes 2. 2 divided by 2 is possible, and we have reduced 1, so we put it here. So 2 divided by 2 will be 1. 13 divided by 2 is not possible, so we need to reduce it. So I'm going to reduce this, so it becomes 12. I'm going to reduce 1 from it. I'll put it there. So 12 divided by 2 is 6. 16 divided by 2 is 8. And 0 divided by 2 is 0. So 1,680. Now this can still be divided by 2. I'll do that. So divide it by 2. Now, 1 divided by 2 is not possible. So we need to reduce this. It becomes 0, and this becomes 16. So 0 divided by 2 is 0, and 0 to the leftmost is not important. 16 divided by 2 is 8. 8 divided by 2 is 4. and then 0. So it's good so far. We got 840 divided by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. 0 divided by 2 is 0. Still good. Divide by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. And 0 divided by 2 is 0. Still even. So divide by 2. 2 divided by 2 is 1. 1 divided by 2 is not possible. So we reduce it. It becomes 0. And this becomes 10. So 0 divided by 2 is 0. And 10 divided by 2 is 5. And now we have an odd number. And odd numbers cannot be divided by 2. So this is odd. We cannot divide this by 2. So we need to check if it's divisible by 3. And how do we do that? We add the digits. So if we add them, we get 6. And is 6 divisible by 3? Yes. So if the sum is divisible by 3, then the number is divisible by 3. So we will divide it by 3. So let's do that. Divide by 3. 1 divided by 3 you can't, so reduce it, becomes 0, this becomes 10. So 0 divided by 3 is 0. 10 divided by 3, you can't, reduce it, becomes 9, and this becomes 15. So 9 divided by 3 is 3, and 15 divided by 3 is 5. 35. Now 35, is it divisible by 3? Let's check that out. So if you add them, 3 plus 5 gives you 8. Well, 8 is not divisible by 3. So in this case, it is not divisible by 3. So we move on to what? To 5. Is it divisible by 5? Yes, because it starts with 5. It ends with 5. So if the number ends with 5 or 0, it is divisible by 5. So we'll divide by 5. And here it just, you don't need really to do long division. 35 divided by 5 is 7. 7 now can be divided by 7, and the answer is 1. So the answer of this prime factoring is 1. So now, let's see. Now we need to get, from these prime numbers, we need to get a sequence. And this sequence has to start with 8. So we need an 8 at the beginning. So let's do that. 8, how do we get 8? We can get 8 from 2 times 2 times 2. So if you multiply these 3 together, you will get an 8. So 2 times 2 times 2 is 8. That's 8. So this is now 6,720 is actually equals to 8 times. What's the next number in the sequence? It is 7. I have to put a circle here on the 7 so that I make sure that I choose it only once. So 7, then times. I need a 6, and we can get a 6 by multiplying 2 by 3. So this is 6. So 8 times 7 times 6 times. I need a 5. We already have a 5 here. So that's our 5. So times 5. So times. I need a 4, and we actually can get a 4 from multiplying 2 by 2. So 2 times 2 is 4, so that's your 4. And that's it. We're done with all the digits, all the prime numbers, all the prime factors. So this is 6,720. It's actually 8 times 7 times 6 times 5 times 4. Multiply these numbers, you'll get 6,720, and they are in a sequence. So how many are they? They are 5 actions that are starting with 8. And this is going to be equals to 8 permutation R. So by comparing these two, we will find out that R is equal to 5. Good. So we found the value of R right here. Since we found this R, we can substitute it here and find what is required. So what is required? So what's required? What we need to find is, they want us to find R plus 1 factorial. Well, we've just found R is 5, so this is going to be equals to 5 plus 1 factorial, which is 6 factorial, and we have memorized 6 factorial before, and we know it is equal to 720. So the answer to this question is 720. And that's it. That's question 6. Okay, let's solve another question now. Let's solve this question, question 7. Let's see what the question says. So this question says the following. The question says that if we are given that n plus 1 factorial ratio to n minus 1 factorial is equal to 72. The question is asking us to find n permutation 0 plus n permutation 5 plus n permutation 2. Okay. So the given part is this part, given that n plus 1 factorial ratio to n minus 1 factorial is equal to 72. From here, we will try to find the value of n. If you find the value of n, then we can solve this easily. So let's try to find the value of n. Okay, let's see. So first of all, guys, what does the ratio mean? Or what does the ratio translate to? The ratio always translates to division in mathematics. So this means that it's n plus 1 factorial divided by n minus 1 factorial equals to 72. And remember, this is not a proving question. You don't take only the left-hand side and you simplify it. No, you take both sides. It's not a proving question. You take the whole equation, you solve it, you try to find the value of n. So let's start. So let's say that we know that n plus 1 factorial divided by n minus 1 factorial is equal to 72. Now the question is, what do we do with this side? What do we do with the factorials? Now, remember in class, I hope that you still remember that we said that we can't do anything in factorials. We can't divide them, we can't multiply them by something. The only thing we can do with factorials is just take them out. The same thing that we do with the bullets in a gun magazine. We can take the bullet out, the next bullet will show up. We can take the next bullet out, the next bullet will show up, and so on. Or we can insert a bullet in, and the bullet that is on surface will just fade inside. So that's the same thing. Which factorial is bigger? N plus 1 factorial is of course bigger. So we can take n plus 1 factorial out. Remember guys, the sequence is n plus 1, the next one is n, and then n minus 1, and then n minus 2, and then n minus 3, and so on. These are the bullets now. We take n minus 1, n plus 1 out, so you get n on top. So if you take n plus 1 out, it will be n plus 1, that's out, multiplied by n factorial over n minus 1 factorial equals to 72. You still have a problem. You can't cancel n factorial with n minus 1 factorial. You need to get the same thing. So what we are going to do is also take n out. So this one will show up. So I'll take n out as well. So it will be n plus 1 times n. I took both out. N plus 1, this one is still there, and n, we took it out, times what is going to be left in the factorial is n minus 1 factorial. So n minus 1 and all the other numbers below it over n minus 1 factorial equals to 72. Now we can simply cross out the n minus 1 factorial from both the numerator and the denominator because it's exactly the same factorial. So we cross it out. So we end up with n plus 1 multiplied by n equals to 72. Now this line can be solved using two other ways. I think we've talked about this, something like this, similar to this in the previous video, which is either the smart way or the donkey's work. And let's start with the donkey's work first. So how do we solve this one? We expand the brackets, we multiply n by both n and by 1. So n times n, we get n squared plus n times 1 is n equals to 72. We transpose the 72 to the other side because this is now a quadratic. So n squared plus n minus 72 is equal to 0. Good. So now we need to factorize this. So it's 2 brackets equal to 0. N squared is n times n. Now the signs, you get a plus here, and plus times minus is minus. You write it there. So it's plus here and minus here. Now you need two numbers. If you multiply them 72, and if you minus them, you need to get 1. These numbers are quite easy. They're 9 times 8. 9 times 8 is 72. If you minus it, you get 1. So you write the bigger number first and the smaller number second. So either n is equal to negative 9, transposing the 9 to the other side, or n is equal to 8. Now you need to remember that this is rejected. And why is this rejected? Because we can't have n to be negative. N cannot be negative, it cannot be fraction, it cannot be decimal. It cannot be 0. It has to be a whole positive number. So this one is rejected. The other one, however, is accepted. So we accepted the value of n is 8. This is one way. We can also find the value of n using another way, a smarter way. This is what I like to call. Now look at this, guys. Let's erase these arrows. We can say that these two factors, which are n plus 1 and n, these are actually consecutive factors. N plus 1 and n, they are consecutive factors. And what does that mean? It means that we can write it as a permutation. Two actions, and the largest of them is n plus 1. Equals to 72 is 9 times 8. 9 times 8 are also two consecutive numbers. They have to be consecutive so that we write them as a permutation. It's two numbers and the largest of them is 9. And here, remember that this is a permutation of two numbers and this is n plus 1. Now if it's the same r, it's the same n. So therefore, n plus 1 is equal to 9. We transpose this to the other side. So n is equal to 9 minus 1, which is 8. So we got the same answer without having to solve a quadratic equation. Of course, remember that you're not limited to one method. As long as your exam is a multiple choice exam, so you can do whatever you like, whatever you feel easier, even if it's the donkey's work. Doesn't mean that it doesn't insult you in any ways. It's just more work, but it's correct. It's mathematically correct. Now, we're not stopping here. Why? Because what is required is the following. It is required to find n permutation 0 plus n permutation 5 plus n permutation 2. Now we have already found the value of n, and we've established that the value of n is equal to 8. So this is going to be equals to 8 permutation 0 plus 8 permutation 5 plus 8 permutation 2. Now look at this, guys. 8 permutation 2 is easily established. It's two actions starting from 8, so it's 8 times 7. 8 permutation 5 is also easily established. It's 5 actions and starting from 8, so it's 8 times 7 times 6 times 5 times 4. However, the last one here, 8 permutation 0, is it 0 actions that's starting with 8? How do we write 0 actions? To find this last one, we will need to refer to the relationship between permutations and factorial. Remember that n permutation r equals n factorial over n minus r factorial. We wrote this formula before in the previous class. So if we substitute now 8 permutation 0 we will get 8 factorial over 8 minus 0 factorial. 8 minus 0 factorial is 8 factorial, so it's 8 factorial over 8 factorial. We cancel them together, we will get 1. So actually, 8 permutation 0 is equal to 1. And it's not only that. You can add a note here. So, a note, this is an important note, you need to remember it. In permutation 0 is always equal to 1. So whatever number here, if it's permutation 0, so the answer will always be 1, because it will be always here be n minus 0, which is n factorial, so n factorial over n factorial will become 1, so it's always 1. So here we have 1 plus 8 times 7 times 6 times 5 times 4. This is 20. 20 times 6 is 120. And 120 times 7 is 840. And 840 times 8 is 6,720. Plus 8 times 7 is 42. You add them together, so you will get 6,763. So this is going to be our final answer to this question. We'll take a small break now. You can take a break, take a breather, relax, drink something cold, refresh yourself, and then come back so that we continue. Okay, let's continue now with some more exercises. This is permutations. And this is page 3. Please make sure that you write these exercises in your copybook. I cannot stress this enough, because your copybook is your main reference for studying at the end of the year. So, we left at question number 7 from exercise 2-2, and now we will continue with some other questions. Let's do question 8. So, question 8 gives us the following information. He says, if given in permutation R is equal to 60, 48, 0. 60, 48, 0. And R factorial is equal to 720. So the question is, find the value of n plus 1 permutation R minus 1. N plus 1 permutation of R minus 1. Okay, good. So let's see this one. So let's start first of all with the given. So here we're given that n permutation R is 60, 48, 0. And we are also given that R factorial is 720. So from R factorial, we can actually right away find the value of R. So because R factorial is equal to 720, and we know that 720 is actually 6 factorial, so therefore R factorial is equal to 6 factorial, which means that R is equal to 6. So now we found the value of R. So we can substitute it here and find R minus 1, which is 5. But we still need n. So that we can find this, we still need n. Where do we find n from? We'll find it from here. Now, since this one is a permutation, then we can always use prime factoring to see this number, to strip this number into prime numbers. So let's do that. So we have 6480, and we will do a process of prime factoring here to get this number as the product of some prime numbers. And the list of prime numbers is always 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. Okay, and we will start with the 2. This is even, so it's divisible by 2. And if all of these numbers can be divided by 2 with no remainder. So 6 divided by 2 is 3, 0 divided by 2 is 0, 4 divided by 2 is 2, 8 divided by 2 is 4, 0 divided by 2 is 0. We still have an even number, we can divide that by 2. Now we need to reduce the 3. 3 divided by 2 cannot be done, so we reduce it by 1, becomes 2, and here becomes 10. So 2 divided by 2 is 1, 10 divided by 2 is 5, 2 divided by 2 is 1, 4 divided by 2 is 2, and then we have a 0, because 0 divided by 2 is 0. I think this one is a little bit off our camera, so I think this is better. Okay, so let's continue. Dividing by 2 again, since it's even, you see that. So divide by 2. 1 divided by 2 is not possible, so we reduce it, becomes 0, and this becomes 15. So 0 divided by 2 is 0. 15 divided by 2 is not possible, so we reduce it. It becomes 14, let's write it there, and here this becomes 11. So 14 divided by 0 is by 2 is 7. 11 divided by 2 is not possible, so we reduce this 11, it becomes 10, and this becomes 12. So 10 divided by 2 is 5. 12 divided by 2 is 6, and then 0 divided by 2 is 0. I hope this is clear so far. So this is still even, we can divide it by 2, so I'll divide it by 2. The 0 on the left is not important. 7 divided by 2, we can't. We reduce it to 6. This becomes 15. So 6 divided by 2 is 3. 15 divided by 2, we can't. Let's write it here. 14, and this becomes 16. So 14 divided by 2 is 7. 16 divided by 2 is 8, and 0 divided by 2 is 0. It's still even, so we still can divide it by 2. So let's carry on and divide this by 2. Now, 3 divided by 2 is not possible. Reduce it, becomes 2. This becomes 17. So 2 divided by 2 is 1. 17 divided by 2, reduce it, becomes 16. This becomes 18. 16 divided by 2 is 8. 18 divided by 2 is 9, and this is 0. So we can still divide this by 2, but this is going to be the last time we divide by 2. Let's see. So divide by 2. Reduce this, becomes 0. This becomes 18. So 0 divided by 2 is 0. 18 divided by 2 is 9. 9 divided by 2 cannot be done, so this is 8, this is 10. 8 divided by 2 is 4, and 10 divided by 2 is 5. So we can't divide by 2 anymore. So now we can cross out the 2. Okay, so let's now try 3. 9 plus 4 plus 5 is 18. 18 is divisible by 3. So this number is also divisible by 3. So let's do that then. Let's divide this number by 3. Okay, so dividing by 3. So let's choose 3 here. 9 divided by 3 is 3. 4 divided by 3 is not possible. So we reduce it, becomes 3. This becomes 15. 3 divided by 3 is 1. 15 divided by 3 is 5. 315. Add them together, you'll get 9, which is good. So 9 can be divided by 3. So let's divide by 3. So by 3. 3 divided by 3 is 1. 1 divided by 3 is not possible. Reduce it, 0, 15. So 0 divided by 3 is 0. 15 divided by 3 is 5. Well, we have seen this number in the previous question. 10, 5, we can divide it by 3 because if you add them, you get 6. So you can divide this by 3, 105. So 1 divided by 5 cannot be done. This is 0, this is 10. 10 divided by 3 cannot be done directly. We reduce it. It becomes 9. 9 divided by 3 is 3. And here this is 15. 15 divided by 3 is 5. 35 cannot be divided by 3. We will divide it by 5. We will get 7. We will divide that 7 by 7. We will get 1. And that's our number now. It's a long process, but we reached to the end now. So let's see. We have 60. We have 60,480. We will write it as follows. Now look at this. We take the largest odd number, which is 7. So we have a 7. Do we have a 6? So this is 7. Do we have a 6? Yes. Here, this is a 6. So we take a 6. Okay, we can say 5, right? So we can say 5. That's here. We can take 4. That's here. But look at this, guys. We've already found R, and R was how much? It was 6, right? So we need 6 numbers, 6 actions. Okay? We don't need more than that. I have 7 times 6 times 5 times 4, which is good. Now I am left with 3 2s and 2 3s. Well, this together, 2 times 2 times 2, will give us 8. So I can put an 8 here. And 3 times 3 will give us 9. So I can put a 9 here. So this is now 1, 2, 3, 4, 5, 6 numbers, just as what we found as the value of R. Because R is 6. If R is 6, that means that we need 6 actions. We need 6 numbers that are consecutive. And these are 6 numbers that are consecutive. You can try other combinations, but you always have to get 6 numbers that are consecutive in this question, since you found R is 6. So the proper sequence is this sequence. So 60, 80, this means that 60, 80 is actually 9 permutation 6. 6 actions, and the largest one of the actions is 9. And this is equal to n permutation R, according to the question. So R is 6, we found this, we established this before. But here n is how much? So therefore n is equal to 9. Okay? So now we found n and we found R. Now what you need to know is what's required. So what is required? We need to find n plus 1 permutation R minus 1. N plus 1 is 9 plus 1, so this is 9 plus 1 permutation 6 minus 1, which means 10 permutation 5. And then if you want to evaluate that, you can say it is 10 times 9 times 8 times 7 times 6. It is highly unlikely that you have numbers like these in the exam, since the product of these numbers is something large. But at home we can do this. I mean, we can just multiply them. We can find the product of these numbers, and the product of these numbers is going to be 30,240. So this is going to be the value of 10 permutation 5, or 10 elements arranged or selected, where we select and arrange only 5 of them. So this is now question 8. I hope that this question is clear. Just a quick revision what we did. We found the value of R from here. So R was 6. From here we got this number, and we did the prime factoring of this number. We know that this R is 6. So we were looking for 6 numbers in a sequence. We found these 6 numbers in a sequence. The largest number of these numbers was 9. So we wrote 9 permutation 6, and from that we found that n is equal to 9. Now after finding n is equal to 9, we substituted 9 here and 6 here. So 9 plus 1 was 10, and 6 minus 1 was 5, and we evaluated this as 5 actions starting with 10, and we got 30,240. And this was example number 8. Okay, let's do another example now. You remember, you can always pause the video whenever you like. Whenever you feel tired, pause the video, take a break, relax, and come back to it. Continue until you finish the whole thing. Please, this is your responsibility, this is your education. You need to take good care of your education. These things are going to be important for a lot of you in their college life. And we're doing our best now, and I hope that our best is going to be enough. Let's do another one. So let's solve question number 10. So in this question, we are given that x plus y permutation 4, x plus y permutation 4 is equal to 360. And we have another thing. It's also given that 2x plus y factorial equals to 5,040. So what is the question then? The question is asking us to find y permutation x times. Okay, good. So how do we do this one? Let's see. I usually prefer to start with the factorial part, since the factorial is easy. It's a lot easier from the permutation part, though the permutation part is also easy here. You look at this now, 2x, because 2x plus y factorial is equal to 5040. We know that 5040 is actually 7 factorial. So that means that 2x plus y factorial equals 7 factorial. So therefore, 2x plus y equals to 7. Now you have to stop here because you can't continue anymore. You have two unknowns, which are x and y. I'm sorry for that. Okay, you have two unknowns, which are x and y. And since you have two unknowns, you cannot carry on with one equation. You need two equations. So this is going to be now called equation 1. Where will you get equation 2 from? You can get it from the permutation for sure. But for the permutation, you need to prime factor 360. Okay, let's do that. Let's try to be quicker this time. So I'm going to divide by 2. 360 divided by 2 is 180. Divide by 2, you get 90. Divide by 2, you'll get 45. 45 can be divided by 3, you get 15. By 3, you get 5. Now by 5, you get 1. This was quick, but I knew the multiplication table of 360 pretty well, and you can always do this. You don't have to go digit by digit unless the number is really complicated. Now this is good. So from the permutation, we see here that we need 4 numbers. 4 numbers in a sequence. So let's try this out. So 5 is the largest odd number. I'm going to start with it. Okay, do we have a 4? Yes, we have a 4 right here. We have a 4. I can't say 3 and 2, because if I say 3 and 2, then I'm left with another 3. But I can take 3 only. I can take 3 here, and then take these two together and take them as 6. So these two together are going to be 6. So this is 6. So that means that this is 6 permutation 4. So from the other part, which is here, so therefore x plus y permutation 4 equals 6 permutation 4. Good. So this means that therefore x plus y is equal to 6. Now I have another equation. This is equation 2. So we have two equations now. I can solve them simultaneously. So we can of course use either elimination or substitution, whatever method you like. So I'm going to say here solving equation 1 and equation 2 simultaneously. I think y is let's see, 3 and 3 maybe. Okay, let's see. I'm not sure. Let's see. So let's solve them together. How is that? So I'm going to use elimination. I will multiply this equation, I'll multiply it by -1. Everything here. So 2x plus y equals 7. Multiply that one by negative, so minus x minus y equals -6. So now we use elimination. This part is going to be eliminated, positive y and negative y. So 2x minus x is x, and 7 minus 6 is 1, so x is equal to 1. So we put this one here, so we substitute in equation 2. Of course, in whatever equation, it does not matter. 1 plus y is equal to 6. Remove this to the other side, transpose it, so y is equal to 6 minus 1, so therefore y is equal to 5. So 2 times 1, 2, plus 5 is 7, and 1 plus 5 is 6, which is good. So x is 1, and y is 5. And what is required, what we need you to find required, is y permutation x, which means 5 permutation 1. So it's one action and you write 5. So that's it. 5 permutation 1 is equal to 5. Actually, this deserves a note. You can write a note here. This note is whenever you have a permutation of n elements and there is 1 here, so n permutation 1, the answer is always n only. Remember that n is n factorial, but n1 is n only. And you can write this and also highlight it. So this is something that you need to remember a lot. Okay, so with this example, we'll take a small break now again, and we will come back to solve some more examples. Okay, so we are back from our break and into the last part of this class. And in this part, we'll just speak about the homework. So your homework for the next class. Please submit this homework by tomorrow. You can write in the paper, take a photo of it and send it to me. But do not send it in the group, just send it to me as a conversation in WhatsApp. So your homework is questions number 5, 9, and 11. Again, 5, 9, and 11. Now you might notice that we have here some word problems starting from question 13, but we will actually not discuss these word problems in the next class. Instead, we will start with combinations in the next class. The reason that we will not discuss the word problems is because we also have some word problems in combination, and they're usually confused with the word problems in permutation. And because I don't want you to be confused between these two, we'll discuss them together. and see the differences between the word problems of permutation and the word problems of combination. When do we use permutation and when do we use combinations? So that's all for today. I hope that you're safe at home. You're not leaving your houses unless it's necessary. Please try to be safe. Keep your hands always clean and keep them off your faces. And I wish you all the best of luck and health as well. See you inshallah again later.